If G and G prime are the centroids of two triangles ABC and A prime, B prime, C prime, then we need to show that the sum of the vectors A prime plus B prime plus C prime equals to 3 times the vector G prime. Okay, let us try to understand the problem graphically. So we'll be considering two triangles. So we consider the triangle ABC and the other triangle having the vertices A prime, B prime, C prime. Now we will be considering a point O, which is going to be the origin of some coordinate system. Now this is going to help us define the position vector of each of the vertices of the triangle. So we'll suppose that the position vector of A of ABC is defined by A prime. Position vector of vertex B, let it be defined with B vector, and position vector of vertex C is defined by the vector C. Similarly, we can define the position vector of the triangle A prime, B prime, C prime with respect to that origin. Let's call the position vector of the vertex A prime as A prime vector. So B prime will be B prime vector and C prime will be C prime vector. So here we're going to suppose this. So let OA vector, so this is defined by the vector A. OB vector, this is the position vector of the vertex B, that's defined by B vector. OC vector is going to be C vector. Then we have OA prime vector, so this will be defined by A prime vector. OB prime vector is going to be defined by B prime vector. And then OC prime vector will be defined by the vector C prime vector. Now let's try to define the centroid of each of the two triangles. So we have suppose the centroid of the triangle ABC at G and the centroid of the triangle A prime, B prime, C prime at G prime. Now centroid means it's the point where the three medians of the triangle ABC coincide. So let's consider the triangle ABC. In triangle ABC, G is the centroid. Now, in terms of the position vector OA, OB and OC, we can define the position vector of the centroid G as OG vector given by A vector plus B vector plus C vector whole divided by 3. Similarly, if we consider the triangle A prime, B prime, C prime, and in this particular triangle, G prime is the centroid. Now we can also define the position vector of the centroid of this triangle. So this will be given by A prime vector plus B prime vector plus C prime vector whole divided by 3. Fine. Now we'll try to prove this. We'll start from the right hand side. So on the right hand side, we have 3 times G prime vector. Now in terms of the position vector, we can define G prime as, we'll take 3 as the common vector. So we have OG prime vector minus OG vector. Since we have the value for OG prime and OG vector, so let's substitute these values. So we have 3 times. So in place of OG prime vector, we have A prime vector plus B prime vector plus C prime vector whole divided by 3. Minus OG vector will be A vector plus B vector plus C vector divided by 3. Now we get A vector plus A prime vector plus B prime vector plus C prime vector minus A vector minus B vector minus C vector. So we can combine A prime vector with A vector such that we get A prime vector minus A vector added to B prime vector minus B vector plus C prime vector minus C vector. The reason why we are writing in this particular fashion, because A prime corresponds to OA prime vector minus A vector will be simply OA vector. Then this is added to B prime vector minus B vector, but in place of B prime vector we have OB prime vector minus B vector, which is simply OB vector added to, so C prime vector will be OC prime vector minus C vector, so that's OC vector. Fine. Now what is A prime vector minus OA vector? So this is simply given by AA vector, AA prime vector. Then OB prime vector minus OB, this is going to define as B prime vector added to C prime vector, and this is the expression on the left hand side. So thus we have successfully verified that A prime vector plus B prime vector plus C prime vector is going to be equals to G prime vector, where G and G prime are the centroid of the triangle ABC and A prime B prime C prime.